For our next example, we want to find the 6 trig functions of theta if the point in question is -2, -4. So the first thing we want to do is draw our diagram. So the point -2, -4 is in what quadrant?
Two. No, 3.
Oh my goodness. Quadrant 3, yeah, it is in the third. Okay, so let's go over here and let's draw that. And technically all we need is quadrant 3. So the point -2, -4 is somewhere down here, right? Okay, and then your R value is always extended from the origin to that point. So that's going to be R. So we're going to come from here to here. Then you're going to draw the triangle, and be careful not to go to the y-axis, always to the x, and trap that rotation. So the angle is actually all of this. That's theta. You always start from the positive x and draw your theta. Then to trap the triangle, you just go to right there. Does that make sense? Okay, that's your right triangle. And from there, we're going to label the x, the y, and the r. So the x value is -2. What's the y value?
4.
-4, and you always keep the signs for x and y. So it's -2, -4, and then we have to go use the Pythagorean theorem to find the r value. So if x is -2, y is -4, so we have -2 squared plus -4 squared has to equal the r value squared. So that gives us +4 plus 16 is equal to r squared. Be careful that when you square a negative that you make it positive. A lot of people forget that and they end up messing something up. That gives us that r squared equals 20, which means that r is equal to the plus or minus square root of 20, technically, but because it's in a trig situation, we only keep the positive for r. The r value has to be positive. So r is equal to positive square root of 20, which reduces to 2 square root of 5. And you do have to simplify and rationalize all radicals. So there's your r value, 2 square roots of 5. So let's jot that down. We know x, we know y, and now we know r. And once you know those things, you shouldn't have any trouble. You just use the definitions, well, assuming like you have them memorized. You use the definitions and you just stack them up and clean them up. So the first one we'll do is sine. Sine is always y over r, which in this case is -4 over 2 square roots of 5, which will reduce to -2 over the square root of 5, and will rationalize to -2 square root of 5 over 5. Do I need to show you that, or you understand what I did there for rationalizing? Does anyone need to see rationalizing? Yeah, you just multiply top and bottom by the square root of 5. And then the top is -2 square roots of 5, and the bottom is +5. And that is the sine of theta for this situation. So I'm going to give you a minute. I'm going to pause it. I'm going to let you guys go through and try to find the other 5, and then we'll talk about it. So what'd you guys get for cosine? Cosine is x over r, right?
-2 square root of 5 over 5.
So it's -2 over 2 square roots of 5. So it is negative. The 2's reduced, so that gives you -1 over the square root of 5, right? And that just becomes negative
Square root of 5.
square root of 5 over 5?
Yeah.
Negative square root of 5 over 5. Alright. Then tangent. So tangent of theta is equal to y over x, which is easier because it doesn't have a radical. So that's just -4 over -2, which is +2. Cotangent
X over y.
is x over y, or you can think of it as the reciprocal of tangent, however you want to do that, which is -2 over -4, which is +1/2. Then there's secant. Secant is r over x. It's the, if you forget, it's the reciprocal of cosine. So these two go together. So it's just the reciprocal of this. R over x is equal to 2 square root of 5 over negative 2, which in this case is just negative square root of 5. And finally, there is cosine, which is r over y. And in this case, 2 square root of 5 over negative 4, which reduces to 1 square root of 5 over 2, so negative square root of 5 over 2. So these are pretty easy. They're just tedious. You know, it takes time, but you have to have them memorized. You can't really do much if you don't. And be comfortable using the Pythagorean theorem and drawing them and labeling the triangles and whatnot. On a quiz or test, because it takes so long to do all 6, I will normally just ask you to do 1. You know, so that wouldn't take very long. So I would just pick any one of the 6 and ask you to do it. Occasionally, maybe 2. Your book, however, makes you do all 6 every time because they figure that's the best way for you to memorize it. It's just repetitive. But I'm not going to do that to you on quizzes and tests. I'll, you know, just ask you for a couple of them. So this problem's a little different. We want to find the values of the 6 trig functions for that specific angle. So we want to do 90 degrees. The nice thing about 90 degrees is that when we draw it, so remember that we always start from here and we rotate counterclockwise. So it's actually going to be up here. So somewhere up here is a point. I don't know what it is, okay? But I know that it's on that positive y-axis.
What did you draw a square for 90?
You're not allowed to go anywhere. Where does R have to come from, you guys? R has to come from the origin. So my R has to come from here. So that red line right there, that is R. Make sense? Come on now, think about it. So technically, this is not a triangle. That triangle has collapsed to a line. So in trig, a triangle can be just a line, which is really weird when you think about it. But it has collapsed. It's collapsed to just nothing. If you imagine I take a point out here and I start rotating it. Well, when I start, it's not a triangle, right? But the minute I start moving, it's a triangle. It's a triangle. But then it collapses again to here, and it's just a line. So sometimes when you're on an axis, the triangle collapses to nothing. But you don't worry about it. You know, you just say, oh, whatever. The problem is, you know, well, we don't care. We don't really care what the triangle looks like. This is trig. We don't care, okay? So that's good. But what you have to realize is if you're on an axis, you get to pick the point. You can pick any point you want on the axis. Do you know the point that's easiest to work with?
0, 0.
Well, that's not on there. This is 0, 0. But there are infinitely many points out there. There's 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. You can pick the point if it's on an axis. Always pick the one with the 1 in it. Your numbers are going to be smaller. It's going to be easier. Pick the 1. You could do 0, 2, you could do 0, 3, you could do 0, 4, 0, 5. It wouldn't matter. But you're going to pick the one with the 1 in it. So we know that this point up here is 0 something, and we're just going to choose it to be 1. Does that make sense? Yes? Okay. So we know that we have decided we're going to let x be 0, y be 1, because that comes from the point I picked. And what does r have to be? You don't even have to do the Pythagorean theorem. What does r have to be? It has to be 1, right? Because it's the same as the y value in this case. They're sharing that value. So the r is also 1. Now, if you're not sure, you can come down here and do x squared plus y squared equals r squared. And you'll see that r squared is 1, so r is positive 1. Doesn't matter. Then you just stack them up. So we say in this case, sine, not of theta, because we were given the angle, sine of 90 degrees is equal to y over r.
1.
Which is 1 over 1, which is 1. And guys, that is a fact. The sine of 90 degrees is always 1. Doesn't matter where the point is, ever. The point could be at 0, 5, it could be at 0, 10, doesn't matter. The sine of 90 is going to be 1. It wouldn't have mattered what point you picked and what your r value ended up being. The sine of 90 will always be 1. And we'll actually memorize that a little later on. The cosine of 90 is x over r, which in this case is 0 over 1, so the cosine of 90 degrees is 0. Then we just finish them up. Tangent of 90 degrees is defined as y over x, which in this case, let's see, that's 1 over 0. And anytime you have 0 in the bottom, you mark it as undefined. That's what your answer is. Not error, not no solution, undefined. You have to write undefined. Now, I will take U and D, but that's about it. Those are your options. Undefined. Then the cotangent of 90 is x over y, which is 0 over 1. Now, 0 on top is not undefined. What's 0 on top? 0. And finally, secant and cosecant. So secant of 90 degrees, that's our abbreviation for secant, is r over x, which is 1 over 0, which is undefined. Perfect. And cosecant of 90 is r over y. Remember, if you get confused, it's the reciprocal of sine. So we know sine is y over r. This is r over y. And in this case is 1 over 1, which equals 1. And those are the 6 trig functions for a 90-degree angle. And that's important. Why? Every single triangle, right triangle, has a 90-degree angle in it. So it saves you some work if you have those memorized. So there will come a point where we will be, you may not know them right off the top of your head, but I'll show you a quick trick to remember them, to figure them out and jot down. Right, let's do one more example and then we'll break. Part B. Find the values of the 6 trig functions for an angle theta in standard position if the terminal side is through -3, 0. -3, 0. So we know that x is going to be -3 and y is going to be 0. We're just missing the r value. And that's really the only reason you ever draw them. Do you guys understand that? I mean, technically you don't even have to draw it because we know that x squared plus y squared always equals what? R squared, yeah. That's a fact. I mean, that's a formula. X squared plus y squared always has to equal r squared. So you wouldn't really even have to draw it. We just get you to draw it so you can start to visualize it. Because in some ways, trig is visual, and the better you can see it, the better you'll do with it, I hope. But you technically wouldn't have to draw it. The point -3, 0 lives out here. So that's another time that it falls along the axis. So when it's on an axis, you can't draw a triangle. So one of your values is going to be 0 every time. What angle is that, you guys?
180.
180. Yeah, that's 180 degrees. So our theta ends up being 180 degrees. Not that it really matters, and we were just asked to find it at the point -3, 0. But it is going to turn out to be 180 degrees. All right. What's r in this case? Is r -3 or is r +3?
Positive.
R has to be +3. Yeah, r has to be positive no matter what. If x and y are negative, r is still positive. And you can see that from the Pythagorean theorem. X squared is 9, y squared is 0, and r squared is that. So r squared is 9. And technically it could be plus or minus 3, but remember in trig, we always define r as the distance from the origin. And when we say distance, distance implies positive. So the r has to be positive. The x's and y's don't. So r is +3. All right, so let's see. We're going to find sine, cosine, tangent, cotangent, secant, and cosecant, all of theta. So we're going to do this really quick. Sine is y over r, which is 0 over 3, which is 0. Cosine is x over r. So -3 over 3 is
-1.
-1. Tangent is y over x, which in this case is 0 over negative 3, which is 0. And cotangent is what? X over y. So x over y. Negative 3 over 0 is undefined. And secant is r over x. R over x, which is negative 1 again. And cosecant, r over y. So r over y is 3 over 0, so that's undefined again. Now, what do we call angles that land on an axis? Starts with a Q. Quadrantals, yeah. They're called quadrantals. And here's something that you should go ahead and realize. If you're dealing with a quadrantal angle, and we have been in both of these in example 4, part A and B, your answers will always consist of zeros, undefineds, ones, or negative ones. That's the nice thing about quadrantals. Anything that lands on an axis will only have zeros, ones, negative ones, and undefineds. So that's something you may want to make a note of because it'll help you in the long run. Let's take a quick break right there.